6, 5, 4, stage engine start, 3, 2, 1, boosters ignited and liftoff. Humanity's next great chapter begins not with a roar on Earth, but with the dream of building a home on the moon. The Artemis missions are no longer just about visiting. NASA is preparing to stay. And this time, they're not sending astronauts for quick flag and footprint missions. They're sending builders, scientists, and machines to create the first permanent base beyond Earth by 2035. NASA's vision has evolved far beyond what Apollo imagined. The Space Launch System and Orion capsule have already proven their power, but these are just the first puzzle pieces. The real challenge now begins: how to create a living, breathing outpost that can sustain human life hundreds of thousands of miles away from home, with no resupply ships every week, no air, and no margin for error. The new moon race. The Artemis program isn't just about returning astronauts, it's about redefining the way humans exist in space. The first crewed landing is planned for the mid-2020, with Artemis III marking humanity's return to the lunar surface. But that's just the opening move. NASA's long-term blueprint includes continuous missions, each one adding a new layer of technology and infrastructure. SpaceX's Starship will serve as the first human lander, a towering stainless steel machine that looks more like a skyscraper than a spacecraft. For the early missions, astronauts will live inside Starship's spacious hull for several days, conducting experiments and scouting potential base locations. But NASA knows that a metal rocket isn't a permanent home. The next phase, building, requires materials, power, and most importantly, oxygen. Mining the moon for air. You heard that right. NASA plans to mine the moon for oxygen. Lunar soil, known as regolith, contains massive amounts of trapped oxygen bonded to metals like silicon and iron. Through a process called molten regolith electrolysis, NASA can heat up the dust and extract pure oxygen, not only for astronauts to breathe, but also as rocket fuel. To make this sustainable, NASA's engineers are developing what could become the moon's first piece of infrastructure: an oxygen pipeline stretching several kilometers. Instead of hauling oxygen tanks on rovers, the pipeline would carry gas directly from extraction sites to storage facilities near the base. Even more impressive? The pipeline could be built entirely from lunar materials, manufactured by robotic systems that melt and shape metal like pasta. If successful, this pipeline will deliver up to 10,000 kilograms of oxygen per year, enough to power a self-sustaining base. That means astronauts could live, work, and even refuel spacecraft, all without relying on constant supply runs from Earth. Project Olympus, building with moon dust. Once oxygen is flowing, humans will need walls, roofs, and floors. NASA's $57 million partnership with Icon, a company famous for 3D printing entire houses, might hold the answer. Project Olympus aims to create a fully automated construction system that turns lunar dust into solid structures. Instead of bringing building materials from Earth, NASA will use the moon's own soil. Icon's robotic printers will melt regolith, mix it with special binders, and then harden it with sunlight, forming durable habitats, landing pads, and roads. It's a concept that sounds straight out of science fiction. Machines building a city on another world before humans even arrive. NASA has already tested the material using actual Apollo moon samples to ensure it can withstand radiation, micrometeoroid impacts, and extreme temperature swings. If successful, the first 3D printed lunar shelter could be ready before 2030, a structure designed to house 4 astronauts safely from solar radiation and lunar dust. The dust problem. Moon dust isn't just a nuisance, it's a danger. During Apollo, the powdery surface material clung to everything, scratching visors, jamming joints, and even irritating astronauts' lungs. On future missions, rockets like Starship will unleash enormous plumes of this dust, possibly throwing millions of particles into orbit. To combat that, NASA and Icon are working on permanent landing pads and lunar roads. These solid surfaces will prevent damage to spacecraft and protect nearby structures from debris. Every detail matters because on the moon, a single misstep could mean a mission failure. The new lunar rovers. Once a stable foundation is in place, astronauts will need to move across the surface efficiently. NASA's next-generation Lunar Terrain Vehicle, or LTV, is essentially a space ATV, small, rugged, and adaptable. Astronauts can drive it manually or it can operate remotely and even autonomously. Beyond that, NASA plans to deploy a pressurized rover, allowing astronauts to take multi-day expeditions without wearing bulky spacesuits. Imagine exploring vast craters, frozen lakes of ice, or mountain-sized ridges, all from inside a mini-space home on wheels. This vehicle will play a critical role in mapping out resources like water ice, the lifeblood of the moon base. Spacesuits for the next era. The old Apollo suits were iconic, but they were also stiff, fragile, and barely able to handle the moon's brutal dust. The Artemis generation will wear entirely new suits, built by private aerospace firm Axiom Space. These suits are designed to be lighter, more flexible, and resistant to sharp regolith particles. Every detail, from the joints to the visors, has been re-engineered for real exploration, not just short walks. The suits will allow astronauts to bend, kneel, and carry tools efficiently, making them true builders rather than temporary visitors. Private partners and international support. NASA isn't alone in this mission. SpaceX provides the landers, while companies like Icon build the habitats. Axiom Space designs the suits, and other partners from Japan, Canada, and Europe contribute robotics, life support systems, and the Lunar Gateway, a mini space station orbiting the moon. The gateway will serve as the central hub between Earth and the lunar surface, a place for astronauts to rest, transfer supplies, and prepare for missions deeper into space. Think of it as the moon's airport, orbiting silently, connecting two worlds. What comes next? By the early 2030s, NASA's goal is to have a fully operational Artemis base camp at the moon's south pole, a region that contains permanent shadows and ice-rich craters. That ice will be crucial, not just for drinking water, but also for oxygen and fuel. From this base, NASA will test every system required for the next giant leap, sending humans to Mars. Each mission to the moon is essentially a rehearsal for life on another planet, testing construction, life support, autonomy, and psychology. The moon will become humanity's first true off-world colony, a training ground for the solar system. The future of the moon base. Picture it. Astronauts stepping out onto a sunlit plateau surrounded by silver domes and glowing solar arrays. Robots move silently across the regolith, building new modules while rovers glide down pressurized roads. A nuclear reactor hums softly in the distance, powering greenhouses where plants grow in artificial light. Above them, Earth shines in the black sky, a blue marble reminding them how far we've come. What was once a dream of science fiction will soon be a real, breathing world built by human hands. This is not just about exploring, it's about expanding life itself. For the first time, humans will have two homes in the universe. And from there, Mars will no longer seem impossible. So what do you think? What will the first moon base really look like in 2035? A small outpost or a thriving mini-city of science and machines? Drop your thoughts in the comments. And if you love exploring humanity's next frontier, make sure to subscribe. New episodes every week take you deeper into the future of space exploration, technology, and beyond. Hit that bell so you don't miss what happens next, because the next chapter of human history is unfolding right above us.